Okay, hello everybody. Just wanted to kind of do a quick run through on some of the homework assignments. And we're looking at section 2.5 today. And we're going to work on the question that looks at the heights of randomly selected women again here. These are in inches. And this is a large data set, so I want to go ahead and use Desmos for this. So we'll open the Desmos calculator and paste all these values in that we've got, and we'll compute the mean and the standard deviation. Okay, so real quickly here, let me open, well, I guess I'll do the copy first. So highlighting these, and you do Control C or Command C on a Mac to copy. And then open Desmos, and don't need the graph, so I'll move that out. And so we just say A equals in brackets. I'll do Command V or Control V to paste these. And that is 100 different values. Okay, so initially I just need the mean of those values, mean of A and the standard deviation, like that. And so I've got that. So I'm gonna, these values have one place after the decimal. So I have to round my statistics to two places. So the mean is gonna be 63.02. I'll go ahead and put that in. And the standard deviation, just popping back here, is it says 579, so that's gonna be a 3.58. Like that. And now the percentile for the 66.3, I'm going to have to count how many values are below 66.3. And that might be a little bit of a pain. So I've just highlighted the values that are above it. And I think I'm going to go that route. So 1, 2, 3, 4, 5, above or equal to it, I should say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Lost track. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 values are above or equal to 66.3. So that should mean that 79, the rest of them are below 66.3. I'll check that. And so it says give the z-score now of 66.3. So the z-score, you just take your value, you subtract the mean, and you divide by the standard deviation. Okay, so I've got the mean here and the standard deviation here, so I'll go ahead and do that. So my value again is 66.3. So I'm going to go on a new line, start a fraction by pressing the slash. And again, it's 66.3. We subtract the mean, which was 63.02, just the rounded version, I guess, and then dividing by the standard deviation, which we rounded to 3.58. Okay, so this is the z-score, 0.916. I think we're going to round that to 0.92. Yeah, two places after the decimal here, so 0.92. And then we want a z-score of 53.9 now. Okay, so I'll do the same computation. I could actually just go back and change to 66.3. What was it again? 53.9. So 53.9, just a little change there. Now the z-score is negative 2.547, which I'm going to round to negative 2.55. Like that. This is more than 2 standard deviations below the mean. Remember, the z-score tells you how many standard deviations you are from the average, the mean. So 2.5 standard deviations below the mean. Anything more than 2 standard deviations is unusual. So yes, this value is unusual. And I believe I am done here, 6 out of 6. So that's it for that. Okay, hi everybody. Just wanted to quickly do another homework problem in 2.5. This one I wanted to do on a TI calculator, and I've got my emulator here with the memory already cleared. Just remember, you do on and clear simultaneously to wipe the memory. And I'm going to go ahead and jump into the homework. I'm going to pick a problem I haven't done. So I think I'll jump up to question 2. This one has a smaller data set with it. These are the amethyst woodstar hummingbirds again. Little randomization with these numbers, so they're based on real numbers, but they're not actually real numbers. Anyway, so I've got to key all these values in to the calculator. So over at the calculator, I'm going to just press the data button and start entering the values. So this will take me just a second. A lot of 75s. Oops. Looks like 481s. Okay, 282s. Okay, 83. 285s. 88, just one of those. Oh, I missed an 85. Let me put the other 85 in. Got the 88 and then 89. And then a 93. Okay, so that should be everything. I'll need the sample mean for this data set, so I'm just going to press clear, and then second data. We want one variable stats, which is item 2 on my calculator, and we hit enter through all that. And here's the mean, 79.08. Now we want to round this to one place after the decimal, because the given values have nothing after the decimal. We should do one place more than that. So I guess I'll go 79.1. And for the standard deviation, same thing. We're going to go 6.7 here. Okay, and then the percentile for 80. I'll have to count how many values are less than 80, not less than or equal, but strictly less than. So those are the values less than 80. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 values out of, let me see here. It looks like there's 25, but 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah, 12 out of 25. So that's 48%. You would, the formula says to multiply that by 100. So 48%. So it's the 48th percentile. Just round that to a whole number if it's not a whole number. And then the z-score of 80. So I think maybe there's a formula for the z-score here. Right there, it's x minus mu over sigma, or that's for if you know the population mean, mu. If you know the population standard deviation, sigma. If you know the sample mean, you use an x bar. Sample standard deviation, you use an s. So, right, so over here, I can take the x, which is the 80. I'll start by building a fraction. So 80 and then minus the mean, which is, I guess it's the 79.1. And then we divide by the standard deviation. So that was 6.7. And hit enter. And so it's once again round this to 2 places, it says. So I'll round that to 0.13. So that value is only 0.13 standard deviations above the mean. It's very small deviation. And now the z-score of 61. I'll do the same computation. I can actually on the calculator I can press up twice here and press enter, and then I can actually edit it. So all I really need to do is change my value. I'll just type over the 80, and I'm doing a z-score of 61, so I'll just say 61 instead of 80 and hit enter. So that's negative 2.70 to the nearest hundredth, 2 places after the decimal. So that should be okay. That's unusual, yeah, because it's more than 2 standard deviations below the mean. And let's double check. So we're all good to go here. I got 6 out of 6. So I think we're good to go.